Hi guys. All right, for today's video, we are going to be doing more of the same stuff we've been doing this whole time, but I want the major focus of today's stuff to be on the rate of change or the slope. So yesterday we graphed a whole bunch of stuff that was in the form of y equals something times x, where we didn't have any of these numbers added or subtracted off the end. That meant that we had a line that went right through the origin, right? Every single one of them went through the origin, whether it was positive or negative, and they had some steep lines and some not so steep lines. So we're going to look at that steepness again today, but now I'm adding some more stuff to the end just to make it a little bit different than yesterday. But I want you to focus on the slope, the rate of change, how steep each of these lines are. So we're going to graph two lines, and then we're just going to analyze the slope. So let's start with the first one. I already highlighted this because I'm hoping if you didn't already notice this pattern, I'm hoping you start to catch on to it. Every time I ask you for this rate of change or the slope, I want you to look back, whether it says f of x or it's a y there. If the y is by itself or the f of x, we'll even make this one a y for you right now so it makes it a little bit easier to read. So if the y is alone or the f of x is alone, and it equals something times x plus or minus a number. This is in a specific form where we're able to actually identify the slope right off the top. So I know that my slope or my rate of change is going to be 3. And I know that's going to cross the y-axis at 2. So I can fill that information in right away. I already know that. So once we get better at this, we won't even have to do these tables anymore. But for now, let's just go for it. I'm going to plug in my values and we're going to see how this graph looks. This is going to give me negative 6 plus 2, so negative 4. My first ordered pair is at negative 2, negative 4. Next, we're going to fill in the negative 1. I'm going to evaluate that and write it as an ordered pair. Next one, we're looking at 3 times 0, and then we add 2. This gives me 0 and 2. Next, I'm going to fill in 1 for x. That gives me 5, and my ordered pair is 1, 5. And finally, 3 times 2 plus 2 is 8. So that ordered pair is 2 and 8. So before we even plot these, we know our slope is 2, which means our rate of change. What we're actually talking about when we say rate of change is the change in the y value divided by the change in the x value. So how is the y changing in respect to the x? If we just look at our numbers, look here, this is going up by 3, up by 3, up by 3, up by 3. So this is exactly the same every time. It's going up by 3. Over here, we're going up by 1. So we can look at this right away, and without even graphing it, we can say, well, the y value is going up 3 every time. The x value is going up by 1 every time. So 3 divided by 1 is 1. We can look at what this looks like on the graph too. So negative 2, negative 4, negative 1, negative 1, 0, 2, we're finally off the origin, unlike yesterday, 1, 5, and 2, 8. So here's my line. We're going to look at that slope. So slope is, again, that rate of change. So how does this line go up and over? So when we're talking about slope, again, that's this value right here, the one that's next to the x. So let's look at this for a second. There's this rule in math that says that if you were to find the slope, let's say I used these 2 points. We've been doing this the last couple of days. So this goes up by 3 and over by 1. I want you to picture that now as a triangle, right? 3 units up, 1 unit over. We could do Pythagorean theorem right now to get the hypotenuse. I'm not going to bother, but we could because that's a right triangle. Now let's say we picked 2 other points. Let's say we picked these 2 points, right? This goes up 6 over 2, and we could find that hypotenuse if we wanted to. These are similar triangles. Look at those side lengths, right? They're the same shape, they're just different sizes. So this is twice the size of this one. So we've got similar triangles, and that happens because we have a constant rate of change. This thing is constantly going up 3 over 1, up 3 over 1, up 6 over 2. And we could do this for like one giant one too. Maybe I go this way. Okay. So maybe I could say this is going up 12 units and over 4. That's another similar right triangle. All of these little triangles that I'm making with my linear function as the hypotenuse are similar triangles. All of them are right, and they all have the same rate of change. So no matter how you do this, when you're finding your slope, you could look at your change in y divided by change in x. We could look at how far up and how far over we're going on the graph. We could do it with any variety of triangles. They're all going to be similar triangles, and they're all going to give us that same value. Let's say I took this one. 6 divided by 2 is 3. 12 divided by 4 is 3. 3 divided by 1 is 3. So it really does not make a difference which points I pick. This thing has a constant rate of change. That steepness is the same no matter where I go on my graph. So when we plot all of these, it's asking us...
What is it?
That's raspberry sherbet, Clayton.
Ew.
So it's asking us for the slope or the rate of change. We can either identify it right here from the formula. If the y is by itself or the f of x is by itself, you're just looking for that number right in front of the x. If you're not comfortable finding it from the equation, you could find the change in y divided by the change in x, or you could just count in the graph how far up and how far over. There's an equation we can use too with ordered pairs, but we'll get to that
Is this
later.
ice cream or is this cookie ice cream?
Clayton, that's vanilla ice cream.
Why are you so specific about that?
Specific?
Is it because you're on camera?
We are on camera. We're doing math right now.
Okay.
Let's do our second problem. I was trying to make this video shorter because yesterday's got a little bit long. So let's pick up the pace. So for my second one, we have f of x, which is the same thing as saying y, equals 1/2 x minus 3. I've already identified my slope as the 1/2, and I know that because it's the number that's in front of the x. So I can say 1/2. All right. We can find our slope either by looking at the equation, finding the change in y divided by the change in x, or counting it on the graph. Let's fill in our values so we can do it that way too. I'm looking at 1/2 times -4 minus 3. Half of -4 is -2, minus 3 more is -5. So there's that ordered pair. Next one, we're looking for 1/2 of -2 minus 3. And we're going to write that ordered pair. Now we're looking for 1/2 of 0 minus 3. I just wrote this one wrong. Okay, now I need 1/2 of 2 minus 3. And finally, 1/2 of 4 minus 3. Okay, so we know our slope is 1/2 because we can see it in the equation. Let's say we wanted to look at it this way. Change in y value. This is increasing by 1. It's increasing by 1 every single time. That's a constant. This is increasing by 2. This increases by 2, up by 2, up by 2. So our change in the y value divided by change in x is 1 over 2, right? We increase by 1, we increase by 2. So there's my slope. My y-intercept, we're going to see it when we plot it in a second, or we can find it from the equation. It's just the number hanging out on the end. I'm going to plot these. -4, -5 is right here. -2, -4. 0, -3, 2, -2, and finally 4, -1. Let's draw that line. Remember, today's focus is looking at the slope or the rate of change. Specifically, we want to see how we can compare the slope all over this line using similar triangles. So let's pick a couple of triangles that we can use to find the slope. I'm going to start right here. Up 1, over 2. I could have also made a triangle right here, up 2 over 4. Maybe I wanted to go the other direction. Maybe I want to go like down 1, 2, 3, 4, and over 8. So these are all similar triangles. They're all right triangles, and they are all multiples of each other. So this triangle has a leg length of 1 and a leg length of 2, whereas this one is 2 and 4. That's double the size. This one is 4 times the size. So no matter what we do, let's say we checked the slope for all of these. Change in y over change in x is 1/2. This one, change in y over change in x, we could reduce to 1/2. This one, change in y over change in x, is 1/2. So it does not matter at all which set of points we use on our line to find the slope, because no matter what you do, it's a constant rate of change. So if this is overwhelming to you, don't worry about it. Just pick 2 points. And the whole idea here is recognizing that you're not going to be wrong if you pick a different set of points than me, because these are all similar triangles and they all have the exact same rate of change. So pick any 2 points you want, find the rise over run, so how far up and how far over, and it'll give you your slope. So I have ones for you guys to try on your own. And what I want you to do is, using any method you're comfortable with, I want you to find the slope of these lines. You could do this by identifying the slope right from the equation. You could plot them and count how far up and how far over. You could go on Desmos if you wanted to, input those, plot them, and count how far up and over. Anything you'd like to do, whatever makes you the most comfortable. So go ahead and pause the video, and then you can come back when you're ready for the answers.
Can I have apple juice?
Sure, Henry.
Thank you.